Okay. Hello, everyone. Thank you for coming to this session, Lightning Talk, CNS428. So my name is Dhiraj Mahapatra. I'm the Principal Specialist Solutions Architect. I focus on Amazon Bedrock and Agent Core, and I focus on startup customers. I've been with AWS for 6 years, a little bit more than 6 years. And this aspect of what we are going to talk about as human in the loop, it is applicable to all workflows, microservices, and now we are talking about agentic systems and why this is useful. So just a show of hands, I asked this question before, but how many of you are using agents in production today? None? How many of you are using inferencing, LLM inferencing in production today? So most of them. So what I wanted to show is, how did we evolve from normal assistants to actually autonomous agents, and why autonomous agents are important in this era, and where human in the loop is important to implement, and how can you implement which HITL with some of the mechanics, some of the key takeaways, and a couple of resources that I find very useful for you. Okay? So as this progression, this is a timeline that showed you like how we started with simple generative AI assistants and mostly towards chatbots functionality, but we slowly evolved over time. Right now we're talking about all the way in the right, where we are talking about agentic AI systems. Agentic AI system doesn't mean that it has to be front-ended by a chatbot, right? You can invoke agents asynchronously. Let's say something happened in your system, it emitted an event, and you have an event subscriber that can go and work with multiple agents, right? So agents can work behind the scenes. It doesn't have to be a customer sitting on the front on a chatbot. So that's where we are. As and when you go right, you will see we are focusing higher degree of human oversight to low degree of human oversight when you're moving towards autonomous systems. However, there is a concept of ownership in every aspect. Like when you build applications and you have agents in place, when you run them in production and something goes wrong, you can't blame an agent. It's the developer or it's the person who owns that application has to take the ownership, right? So that's where agentic AI with some degree of human in the loop is very important to build. So before we jump into how and when HITL should be implemented, I wanted to give you a background of how we started with model inferencing, specifically on AWS and where we are right now. And that will give a clear picture of why we should think about human in the loop right from the very beginning when we build agentic AI systems. A couple of years ago, if you have to build or if you have to use a model on AWS, these are the options you had. So as a user, you'll come, you need a compute layer where you have to run a model for inferencing. And some of the options for you were SageMaker. Today we have Bedrock. You can run your model getting from Hugging Face, and you can run it on ECS, EC2, or EKS. And then this is simple example of a chat GPT if you think about it, right? You have a model. You can ask questions, you get answers back, so on and so forth. Then we evolved into systems where you need some context or some history to be maintained in that session or in that discussion so that you can get better results, right? That's why we talked about having a persistent store where you can persist some of the chat history, and then when the LLM is coming back with the response, it can understand the chat history and provide a response. Then we evolved our systems to build contextual responses, right, with chat history as well. So now you have a user calling a level of compute that talks to a model, but before talking to a model, it has to use a vector store to get additional context for your organization or anything. This is simple RAG. Get the vector embeddings and augment that embeddings to the LLM to get a better response. So this is where we were. Excuse me. In this scenario, all of those contextual data is mostly static in nature. So I have my organizational standards. I want to bring my architectural standards. And if I want to use that as part of a vector store, these are all static data that you have to deal with. But what if you actually want to leverage the power of LLMs with real-time data? Right? That's where the discussion around tools and agents come into picture, right? In addition to doing RAG or LLM inferencing, If you have to deal with real-time data, you have to build something like this with agents and a bunch of tools that can go out on your behalf, call an API, execute a database query, and get real-time information. And that information will be augmented to the context of the large language model to do some work, right? Now, this evolves because when you start building agents and tools, the very next step comes into picture is how can I secure the setup? How can I get observability? Because when you build APIs or application, you need that observability in place. So with agent and tools, you will still need the same observability in practice. So you need some inbound authentication on who can call the agents, outbound authentication on who the agent can call to, so on and so forth. And then you need guardrails around Bedrock, some observability using CloudWatch or third-party providers, so on and so forth. This also evolves when you think about concepts like MCP, right? So we are evolving from simple LLM inferencing to how we are building agents today with MCP servers. And if you look at it, now the big picture, how you do agents on AWS, it will look like this, which will have agents running on a set of compute, some memory that maintains history and long-term memory, MCP server integrations for external tools that you want to use, and also A2A integration. If you know, A2A is a protocol that Google came up with for agent-to-agent communication. And while they're doing all of these things, you need observability with CloudWatch or third-party tools. So this is one agent. We're talking about capability of one agent that talks to multiple MCP servers or tools or other agents with some capability of memory and identity. However, when you want to run in production, the actual production scenario will look like this, right? So you'll have an agent in your purview, but then multiple agents in your department, in your organization, and then you have to integrate with external tools, so on and so forth. So you can imagine the complexity that you have to deal with, the chaos of this whole setup that you have to deal with, right? So that's where you have to figure out, like if you build systems, how and when, in which areas that you have to build human-in-the-loop capabilities, right? So you have to find those checkpoints where human judgment is very necessary, and if possible, whatever human insight that was given goes back to the AI system so that it can do a better judgment next time. So what are those points? So, excuse me. Think about high-stake decisions points. So I'll take an example. Like if a doctor has to prescribe a medicine to a patient, you need some intervention and not rely on the entire agentic system to build a prescription for the agent, right? The doctor has to provide some capabilities to, okay, this is a good medicine, I can prescribe. Then there will be cases where you have to deal with irreversible actions. What if money gets debited from one account to the other account, which you cannot undo? What if you completed a transaction which you cannot undo? This is where, those are the high touch points where human in the loop will be very influential. What about regulatory compliance? There are countries and compliance standards where a human oversight is always needed. So finding out those places in the setup, you will have to add some checkpoints where a human can come and provide a decision to move forward. Most important part is the trust building phase. So let's say if you are starting new with agentic AI, it'll be really good to have human aspect in the entire setup so that you're building trust with the system. Once you see that the human is actually repeating the same task and it has figured out that the AI or the agent is actually building what it is supposed to do, then you can slowly remove the human intervention part out. So this is the trust building part, is where if you're doing a proof of concept, if you're starting with agents, then it will become very easy to start with human in the loop and then go from there. Plus, there will be some edge cases and some ambiguity where you will definitely need human in the loop wherever it is necessary. So going back to the big picture, there will be areas where you need human in the loop, where you're dealing with, let's say, MCP server integration, or A2A integration with different agents, or finally when you're sending responses to the customer, right? You need some oversight to see whether, okay, everything is okay. Now we should be good to send responses back to the user or call it completing a task. So what are the, now that we talked about where human in the loop is required, where are the cases where human in the loop can be avoided? Like let's say you have a case where you have confidence in the threshold that you have set. So let's say the agent came up with some response and the confidence score is higher. That's where you can avoid human being in the loop. If you maintain high audit trails and you go through those matrices and you know that the agent is doing or the multi-agent system is doing whatever it is supposed to do, then you can slowly remove the human aspect from the whole setup. If you build a feedback loop, as I was talking earlier, if the human can feed it back to the system, then eventually you will tend to removing the human aspect from the entire setup. And this will give you a good process to gracefully degrade when human aspects are not required anymore, right? So what we are talking about here is a progressive autonomy. So you start with the highest level of control with humans in the place, but you slowly progress toward getting the full autonomy when you have built the trust in the system and for your clients and for your customers. If you want to build human in the loop aspect, in the case of MCP provides this capability called elicitations. If you look at this example, if the request is, what is the flight status, then the MCP server will ask a question, give me a flight number, then I'll be providing your flight status. So this is the core capability of MCP as the protocol, elicitations, you can use it. If you're using step functions as a service to build workflows, then step functions has this capability of wait for callback. The step functions workflow can wait for you until an approval or a task token that is sent back with a success message, and then it'll go. So this is how it works. When you ask for a token to be sent externally, the token will be sent through different applications or to an approver. And if the approver says, okay, everything looks good, then the token is sent back, and then the step functions will resume the workflow execution, and it'll go to the next steps. Now, if you have heard the keynote earlier, we talked about durable functions in Lambda also, right? So durable functions will do the same similar work what step functions has to provide. If you're using tools like LineGraph for your agents, some of the capabilities include like this. You can have a human aspect. If a response is coming back from LLM and the human can approve, if it approves, then it goes to node B or the graph node B or A, and then it goes to graph node C if there is a disapproval. You can change the state behind the scenes if a human is in place. So if a human says, I'm getting an input which says foobar, now I want to change that to bars, and then the next node will get the latest updated value for the underlying state. So these are the ways where human can intervene and change the course of action that the agent was supposed to take. The last one is a human can intervene and say whether I want to execute a tool or I don't want to, or should I execute a different tool. This is in LangGraph. If you're building inter-agent communications with MCP and A2A, then there are other capabilities. So if you take about an example of a travel agent, here is an example which I built using API gateway and A2A as the protocol, which is A2A client in a Lambda function, calls a weather agent, which is again an API gateway with A2A server behind the scenes. And the A2A server sends a push notification back to travel agent saying, what is the weather right now? At this point of time, I can put some HITL aspect of it, either using step functions or other capabilities, and then I feed back that information to a state that the Lambda can use, the A2A client can use, or I can send responses back directly to the user. So this is another example. So now, the other aspect I talked about is when human in the loop will slowly go away when you're building autonomous systems, right? So as continuous agent evaluation grows, you will see the human in the loop aspect will slowly reduce. Now, if you've heard the keynote, we talked about agent core evaluations in preview mode. So that is, if you're running agents on agent core, then agent core evaluation is something that you can use to make sure that you get more autonomy and less human intervention. So as and when you see the evaluation maturity grows, the percentage grows in the x-axis, your human in the loop aspect will grow down. So overall, what we're talking about is when you want human oversight, and you will need it in different places, that's where you need those critical decision gatekeeping capabilities. That's where you need humans. If you have workflows that build and have errors that you have to recover from, you can have a human insight or human present in the place to provide you some capabilities to recover from those errors. You want to build trust and transparency. I talked about this progressive autonomy, right? You start with human controls, and as and when you grow and mature in your agentic setup or multi-agent setup, you can build the trust and the transparency, plus having those agent evaluations in place will help you. And then, most importantly, gracefully degradation. So things break in production. And our CTO also mentioned that in multiple keynotes, that things will break. If you have a capability to fall back and gracefully degrade, why not have human in the whole setup so that the trustworthiness will still be alive and the human can decide how to degrade this whole setup gracefully. So there are some resources here. The QR code will have all the information. This is the blog that I wrote on agentic AI using AWS serverless. There are some technical papers, most importantly the one from Harvard that talks about the human algorithm centaur. The concept of a centaurian system, which is half human and half horse, is well mentioned here in this Harvard paper, so I would encourage you to go read that, and how eventually we should move towards building that centaurian system so that the human and the machines or the AI agents will symbiotically work properly together without hampering each other. It's a sample application in the GitHub that I built using the Lambda functions example that I showed, a travel agent and weather agent, which uses A2A client and server. You can definitely check that out and add a human in the loop aspect. So, yep, this is the lightning talk for you. And if you have questions, we can head down and we can discuss more. But the resources are here to check out. There are resources in the QR code. It also talks about different sessions that I did earlier around agentic AI and AWS serverless. So please check them out. And with that, thank you everyone for being here.